All right, let's jump right in. We're about to look at a cyber warfare platform that is totally flipping the script on AI simulations. Seriously, this is not just another pre-programmed exercise. We're talking about a dynamic battlefield where AI agents are actually thinking for themselves. And this is their core claim, which is a really, really big deal. We're going way beyond simple automation here. We're talking about genuine, unscripted autonomy. The whole idea is that these AIs can reason, strategize, and adapt in real time, almost like a human expert would. And yeah, that is the million-dollar question, right? How in the world do you get an AI to think without just feeding it a playbook of pre-written moves? Well, that's exactly what we're going to break down. So first things first, let's meet the players. And you gotta understand, this isn't just a simple one-on-one fight. Oh no, this is a full-blown digital war fought by entire teams of specialized AI combatants. Here's the kicker. Every single thing that happens here, from the initial snooping around to the final all-out attack, is done by one of these 10 AI agents. There are no humans pulling the strings behind the curtain once the battle starts. The whole thing is set up like a classic cybersecurity drill. You've got your attacking red team versus your defending blue team, 5 agents on each side, and they each have one simple goal: outsmart and crush the other team. And you can see here just how diverse these agents are. Each one is its own unique thing. You've got Spectre on the red team, a recon specialist whose brain is powered by GPT-4 Turbo. Then on the other side, you have Sentinel, a threat hunter running on the newer GPT-4o. So this isn't one single AI. It's a whole crew of specialists, and each one has a different kind of brain. Okay, so how does this unscripted thinking actually work? Let's get into the mechanics of it because it's a fascinating process that completely sidesteps how we traditionally train machine learning models. It all boils down to this really clever 3-step process for every agent. First, they get knowledge. Second, they make decisions with that knowledge. And third, their actual behavior is shaped by a unique digital personality. Now, this is where it gets super interesting. The whole thing starts with what they call knowledge injection. Instead of spending months and months training a model, these agents are basically handed a massive library of real-world cyber intel. They essentially show up on day one as seasoned experts. And we're not talking about a couple of textbook examples here. Each agent's brain is built on a foundation of over 1,500 real-world attack scenarios. This includes stuff cataloged by CISA, that's the US cybersecurity agency. So this is legit, forensic-level knowledge right from the get-go. This is the moment the thinking actually happens. Every single turn, each agent looks at the current situation and makes a call to a large language model, an LLM, to decide what to do next. This isn't pre-calculated. It's genuine, on-the-fly reasoning, powered by some of the most advanced AI on the planet. And to stop them all from thinking alike, to avoid groupthink, the system uses 8 different AI models. We're talking OpenAI's GPT-4o, Anthropic's Claude, Google's Gemini, the whole shebang. This variety makes sure the agents have different ways of reasoning, which creates a way more dynamic and unpredictable battlefield. And finally, to make each agent feel, different, its behavior is shaped by its behavioral DNA. And that's not just a cool name. It literally changes the instructions sent to the AI model, giving it a unique personality and tactical style. So these 5 traits, aggression, stealth, speed, intelligence, and adaptability, are everything. They're what decide if an agent is going to be a cautious planner or a reckless attacker. A high aggression trait, for example, literally tells the AI, hey, I want you to favor the bolder, faster exploits. All right, so we know how the agents think. Now let's see how it all comes together in the actual arena, turn by turn. So every turn is like a little loop. First, all 10 agents think and decide their next move at the same time. Then, the system figures out any conflicts. And finally, the winning actions get played out, which changes the state of the battlefield for the next turn. So what happens if an attacker and a defender try to hit the same system at the same time? Well, the platform has a system for that. It calculates an action score for each agent, based on stuff like how well the move fits their specialty. And here's a perfect example. You've got the attacker, Spectre, going up against the defender, Sentinel. Spectre gets a score of 69.2, while Sentinel gets a 68.9. I mean, it is razor thin, but Spectre's action wins out, and that's the one that gets executed. But you might still be thinking, come on, how do we really know this isn't just some super clever script? Well, as the quote says, The proof is in the price tag. You see, because every single turn involves 10 real API calls to those super powerful AI models, it has a real-world cost. It might seem small, just about 2 cents per turn, but that tiny cost is the ultimate proof. It's the receipt that shows this is genuine AI reasoning, not some pre-programmed puppet show. Okay, so the tech is obviously super impressive, but what does this all mean? What's the real-world impact of an AI that can think and fight like this? The implications are just huge. For one, this system shows what we call emergent strategy. That means the AIs are coming up with complex tactics that nobody programmed into them. They just emerge from the interactions. For human defenders, this is the ultimate training ground. It's like a sparring partner that never gets tired and is always getting smarter. And that leaves us with a really critical question for the future. We've just seen what autonomous AI attackers are capable of. So the real challenge now is, how do we build autonomous defenders that are just as smart, just as fast, and just as adaptive? Because the next frontier of cyber war, it's not going to be fought by humans alone.